All right, so this is a quick review of section P.1, which involves the real number system and some of their properties. And so, as we said in class, the real number system is basically comprised of all the numbers that we use in math for the most part. And so the real numbers is the natural numbers, the whole numbers, integers, rational numbers, and also the irrational numbers, right? Now, we said in class that the natural numbers are the numbers that we use to count. So counting numbers are like 1, 2, 3, 4, 5. So essentially the numbers from 1 up to infinity. Okay, then the whole numbers is where we added in the 0. And again, continued to infinity. The integers is when we add in the negative components. So we have, for example, -3, -2, -1, 0, 1, 2, 3, and it keeps going. The important thing is that they have to be whole, no fractions or decimals. So the rational numbers are the integers plus fractions and decimals but it's got to be decimals that terminate or repeat. Okay, so terminating would be like 1.25, it ends, and repeating would be like 0. Would be like 0.33333 repeating. Remember the repeating, we put the little line over. All right, and our irrational numbers are numbers that are decimals that are non-terminating and non-repeating. So these are numbers like pi, the square root of 2, the square root of 3, essentially the square root of any number that's not a perfect square. Okay? Now the real number system all goes together. So we have all of these real numbers, then one set is inside of the others. So for example, you have here your real number system with rational numbers and irrational numbers. Then part of the rational number system is composed of the integers. Part of the integers is composed of the whole numbers, and then part of the whole numbers is the natural numbers. Okay? And up top, you have examples of those there. Now, if we look at this set of numbers here, which this question is similar to what you found on your pre-test. Looking at this question here, we want to decide which of these numbers is a natural number. So remember, natural numbers are the counting numbers. So I see 2 that should be considered natural numbers. 6/3, because it's equivalent to 2, and 8. Those are the only numbers listed here that we can use to count. Now when we look for our whole numbers, because 0 is not included in this set, our whole numbers are the exact same 2 numbers, 6/3 and 8. Okay, our integers are the positives and negatives, but whole values. So we have -1, -22, which is adding to the +6 and the +8. Our rational numbers is anything that can be written as a fraction or a decimal that terminates. So let's say we keep our -1/4, 6/3, 1/2, -7.5, -1, 8, and -22. And finally, irrational is going to be the ones that don't terminate and don't repeat. So -pi and the square root of 2. Okay? Now we mentioned in class that absolute values measure distance from 0 on a number line. And so the absolute value symbol, of course, is those 2 bars. And because we're measuring a distance from 0 on a number line, our answers are always going to be positive values. So if we look at these examples where we're trying to evaluate, we're going to replace x and y with the values we were given and then apply our absolute values. So here we have 3 plus -7. So 3 plus -7 is -4. So we're looking at the absolute value of -4, which of course is +4. Same idea with b, we're going to replace with the values we were given. Absolute value of 3 is 3, absolute value of -7 is 7, and 3 plus 7 is 10. Okay? We mentioned that in order to find the distance between 2 points, we could find the difference and take the absolute value. So we could do 0.1 minus 0.2 and then take the absolute value of those two things. So if I say this -35 is 0.1 and -23 is 0.2, I can use this to find my distance. So this is like saying -35 plus 23, which is -12, and the absolute value of -12 is 12. Now this section also looks at algebraic expressions, what they are, and how to evaluate them. So an algebraic expression is just comprised of variables, numbers, and usually some form of an operation. So maybe things like 3x plus 10, close that, or 5 minus 1/2 x, things of that nature. If we want to evaluate an expression, we replace the variable with its value and simplify. Okay, so that would mean in this case for 4a, we would do 2 times -2 squared minus 5 times -2 plus 8. Following the order of operations, right, we would work on our exponent first. So -2 times -2 is a +4. Then we would multiply. This is 8 plus 10 plus 8, which is 26. And we can do the same thing with the 0. 2 times 0 squared minus 5 times 0 plus 8. 0 squared is still 0. Anything times 0 is 0. And so this simplifies simply to 8. All right, and the last thing in this section is just properties and operations with fractions. I just picked out a few here that had variables in them so we could remind ourselves of how to do this if there's variables. Okay, so remember that in order to add two fractions, they have to have the same denominator. So in the case of 5a, I have a 10 and a 5, and I need a common denominator. So of course we know the common denominator is 10. So my first fraction can stay exactly the way that it is. However, my second fraction needs to be multiplied times 2 in both the numerator and the denominator. So 2x times 2 is 4x, 5 times 2 is 10. Once I do this, my denominator stays, and I add my numerators. X plus 4x is 5x. And anytime we work with fractions, we should write it in simplest form, and our instructions ask us to. Okay, so both numbers are divisible by 5, so that leaves me as x over 2. Like we said in class, if we're multiplying, we can go straight across the top. 3 times x is 3x. 5 times 6 is 30. And then simplify from there. Both are divisible by 3, so that leaves me with x over 10. And then finally a division, which we didn't really talk about. In a division, we leave the first fraction, we change to a multiplication, and we flip the second fraction. So this becomes 7 times 2, 14. X times 3 is 3x, and there is not a number that divides 14 and 3, and so this is your final answer here.